Hello, welcome to episode 3 of Following the USACO Guide. And now the third problem is soldiers and bananas. A soldier wants to buy W bananas in the shop. He has to pay K dollars for the first banana, 2K for the second one, and so on. And he has to pay IK dollars for the ith banana. He has N dollars. How many dollars does he have to borrow from his friend soldier to buy W bananas? Okay, so this is a more mathy problem. Let's just think about this. So the first banana cost, K. Second cost 2K. Third cost 3K. All the way up until the number of W. So all the way until W. So the total he has to pay, which is the total to pay, is going to be the sum of all this. It's going to be K plus 2K plus 3K plus all the way until WK. And we notice here that we see K as a common term. So we can just take K out, and this becomes 1 plus 2 plus 3 all the way until the W. And this is a very common sum, which is just going to be W times W plus 1 over 2. So we don't have to write a for loop to just add all the numbers together. We can just quickly figure it out in constant time. So now it's going to be K times this value. So we now know the total to pay, and N is how much he currently has. So if the total to pay is bigger than how much he currently has, then he has to pay. And he has to pay total to pay minus N amount of gold, and he has to borrow this from his friend. Otherwise, if total to pay is less than equivalent to the amount of money he currently has, then he doesn't have to borrow any money, so we can just output 0. Right? Oh, sorry about that, yeah. So that's all it is. So, yeah, we have to code this up now, and so what do we get again? K, N, and W. And to be safe, since we're dealing with a billion, is there a chance of overflow? W is no. Put K in 1,000 times. So let's check if we can ever get overflow, right? Actually, let's move you to the side and move you here so we can read you both at the same time. So, can there be overflow? I was thinking maybe we should use a long, but let's just clarify that an integer is more than enough. So so let's just take the worst case scenario. K is 1,000, W is 1,000, and N is a billion. In this case, the total to pay is going to be what? K, W plus 1 over 2. So this is 1,000, this is 1,000, this is also 1,000, so this is going to be 1e9 over 2, so this is still within an integer, so that's fine. And then any subtraction, no other multiplication or division aside from that. We just check if this value is bigger than or less than equal to n, which is guaranteed to be a billion. So yeah, we can just use an integer fully for this problem. Okay, so we're given K, N, and W. Now let's get this problem in. So we want K and W, C and K and W, and now we want the total to pay, which is going to be, what we write that? We wrote it as K times W times W plus 1 divided by 2. Let this be. Does that make sense? Yep. And now we said if the total to pay is bigger than n, we know how much we want to pay, otherwise it's 0. So if total to pay is bigger than n, our answer is just going to be total to pay minus n. Otherwise, we just output 0, and that should work. Here it passes. Yeah. Okay, that looks good. So I can just copy this, go here, submit. And voila. Thanks for watching.